And we're back. Okay, so again, this is just a review over chapter 13. Everything from chapter 13 is fair game on this. So jumping all the way back to just right triangle trig, sine, cosine, tangent, SOHCAHTOA, cosecant, secant, cotangent, inverse trig, rotation, angles of rotation, all of that stuff, all the way through the unit circle, inverse trig, through law of sines and law of cosines. So, are there any requests? I do take requests. Yes, sir.
Number 2.
Number 2. Let's take a look at number 2. A surveyor whose eye level is 5 feet above the ground determines the angle of elevation to the top of an office building to be 32 degrees. If the surveyor is standing 26.5 feet from the base of the building, what is the height of that building to the nearest foot? So what should you always do when we do one of these problems? Draw a picture. Become an artist. And here's the surveyor. He's looking up to the top of an office building. Yeah, I think we're just closer to it in perspective. 5 feet above the ground, eye level is 5 feet here. Determine the angle of elevation to be 26.5 degrees. So that theta is 26.5 degrees.
Oh, 32 degrees.
Oh, whoa. 32 degrees. I'm sorry. I was reading the wrong.
Why is this guy so short?
But I is 5 feet up. So, excuse me. So the angle is 32 degrees. He's standing 26.5 feet away. That's the 26.5. What is the height of the building to the nearest foot? So I want to find x. Now remember that x is that piece in there. So don't forget to add back on the 5 feet in the end. Right. What trig ratio is going to do that for us? Sine, cosine, or tangent? What do you call a mathematician who's been out in the sun for too long?
Vitamin A.
What?
A tangent. A tangent.
He's a gentleman that can.
The tangent. Get it?
Why would you use tangent?
Please tell me you get it.
Because this is the opposite and this is the adjacent. So tangent 32 is equal to the opposite x over the adjacent 26.5. And I just multiply the 26.5 over to the other side. So 26.5 times the tangent of 32 gets us 16.6. That's x. And then I add back on the 5 feet, 21.6 feet. It's like a two-story building. Good there? What other requests would you like?
I mean,
I can if you want to.
I guess 16.
16?
You guys draw.
Is that the last one?
Yep.
Yeah, that's a good one to do.
Who wants to, guys? See?
What am I implying here with this problem? What could I possibly get? 0, 1, or 2 triangles. This is an ambiguous case problem.
Oh.
One where I don't give you the diagram would be one where I ask you, okay, figure out whether there's going to be 1, 2, or no triangles at all. Okay? And on the test, there will be no answer blank for you. You'll have to just show all the work and box your final answer. Because if I were to give you answer blanks with angles and stuff, that would imply that there would be a triangle. So I'm not going to imply that there would be even a triangle. So you have to figure that out. Okay? So here is angle A. Remember, always put angle A at the bottom. There's 39 degrees. Side A is across from it, so that's 14 centimeters. B is 20 centimeters, so this is angle C and side C. Remember, for the ambiguous case problem, the only thing that you can do first is find angle B using the law of sines. So we say sine B over 20 is equal to sine 39 over 14. Right? That's the only thing that we can find at this point. So we cross multiply and divide 20 sine 39. We divide that by 14. So we get sine B is equal to that decimal. We take inverse sine of that decimal, and we get 64 degrees. So B is 64 degrees. Now, that tells me right away that there is at least one triangle. 0 triangles is gone. That's not an option anymore. So, case 1 exists. Its angle B is 64 degrees. We will eventually have to find its angle C and its side C. Let's check for the existence of case 2. Its angle B would be the supplement of the case 1's angle B. So 180 minus 64, which gets us 116. Let's check to see if it exists by finding angle C. Right? Angle C determines whether the second case exists. If this comes out negative, it doesn't exist. So 180 minus 116 minus 39. Case 2 exists. So we've got 116 and 25 as my angle measures. So to find this case 2 side C, I would say sine 25 over C is equal to, and then that angle side pair I was given, sine 39 over 14. So we cross multiply and divide 14 sine 25, divide by the sine 39, which gets us 9.4. So that's case 2. We jump back to case 1. We say 180 minus 64 minus 39. If that's my side, my angle C is 77 degrees for case 1. And now we finish off case 1 using this angle C. Sine 77 over C. Well, I shouldn't have done it right there. I don't have enough room. Sine 77 over C is equal to, again, the angle side pair that was given, sine 39 over 14. And we cross multiply and divide that. 14 sine 77 divided by sine 39. 21.7. Both of those are my answer. Questions about that? Okay. What other questions would we like to see? 14? Got it. Find the area. Right, find the area. Area, remember the area formula is 1/2 AB sine C, right? 1/2 times A times B times the sine of C. What does that mean? That means when I have a side angle side relationship in a triangle, that I can take 1/2 times the 2 side lengths times the sine of the included angle. Area is equal to 1/2 AB sine C. So area is equal to 1/2 21 30 sine of 11. Because that 30 sine 11 is really equal to the sine of that, or of the height of the triangle. 0.5 times 30 times 21 times the sine of 11. 60.1 square kilometers. Yes. Short. Not 12?
No, we were just asking the same question.
All right, here we go. You guys are weird. That's, that whole table over there, I don't know about that whole table over there. All right, solve each equation round to the nearest tenth. So let's find each one. Now, remember that if we solve this equation, we solve each of these equations, and we get an answer that falls within the restriction, perfect, life is good. I don't need to touch it at all. But if we don't have what's in the restriction, we have to kind of rework it in a way to fit it within the restriction. So, you know what, let me just get rid of this down here. All right. So sine theta is equal to 0.45. This is A. So that would mean theta is equal to inverse sine of 0.45. So what is that? Let's plug that into our calculator. Inverse sine of 0.45 gets us 26.7 degrees. So theta is 26.7 degrees. Is that within our restriction? No. So the only other place with a sine value, with a y value of 0.45, think about it on the unit circle. So 0.45, somewhere halfway through. That's why we're seeing a 26 degree angle. And then this piece over here would have that same reference angle, that same 26.7. So to find the full angle of rotation of this, we need to take 180 minus my 26.7. 180 minus 26.7. Enter. 153.3. Does that fall within our restrictions? Yeah, that's between 90 and 27. Yeah.
Did you always subtract it by 180?
It all depends. You have to draw it out and reason it through. If it's sine, usually yes. If it's tangent, definitely not. Yeah, and we'll see why here in a second. Take a look at cosine. Take a look at cosine. Cosine theta is equal to negative 0.32. So theta is equal to inverse cosine of negative 0.32. Come on. So 108.7. Is that within my restriction? No. Okay. Then where is the other one with a cosine value of negative 0.32? Well, is cosine x or y? Cosine is x. So therefore, when I'm looking at where the x value is negative, oh, that means it's right back there. Right? That's negative 0.32. So it's up here and down there, which makes sense. Isn't this angle, doesn't that look about 108? Where is the other angle with that same reference angle? Down there. Now, be careful. 108, I keep saying reference angle, but 108 is this measure right here, right? And that means that's the same angle of rotation now in the negative direction. So again, you have to kind of logically reason it through, geometrically reason it through how am I going to figure out what this angle is? Well, if this full rotation is 360 degrees, and then this is 108.7 back, isn't that a negative rotation of 108.7? So this is technically 360 take away 108.7. Oops, 108.7. Okay? Again, there's no set formula to use. You just have to reason it through using reference angles, using angles of rotation, whatever. So 251.3. Does that fit within my restriction? Yes. And then the last one here for tangent. Tangent theta is equal to negative 2.3. All right, so that means theta is inverse tangent of negative 2.3. So negative 66.5 degrees. Does that fall within my restrictions? No. All right, well, let's draw out where is negative 66.5 degrees? Well, it's down here, right? That's my theta. Where else, see, this is what you have to think about with tangent. Where else is tangent negative? In the second quadrant. First and third quadrants, tangent is positive. Second and fourth quadrant, tangent is negative. So the only other place with this same tangent value is up there with that same reference angle. Notice those vertical angles in there that I just drew? What's my reference angle? What is that blue angle? 66.5 degrees. So to find that, oh, you know how, remember when I said definitely not to the 180 minus? I shouldn't have said definitely not. I'm contradicting myself. 180 minus 66.5, 113.5. Sometimes I should have said.
What is it normally?
You just have to go by whether it's positive or negative. So if we end up getting a tangent that's in the first quadrant, I've got to use that same reference angle down here, which then we'd be doing 180 plus that reference angle. You know? Say, like for example, if I said tangent theta is equal to 0.5, or no, that's a bad one. Inverse tangent of 10, 84 degrees, right? So that means in my first quadrant, let me get a new sheet of paper here. That means within my first quadrant, 84 degrees. Up there somewhere. Right?
I'll get those right away first thing in the morning.
Well, I was in your room at like 7:26 and you weren't here yet, so it's gonna.
That's a lie.
So here's my angle, 80 some degrees. 84 degrees. The same place with that tangent value is down there with that same reference angle. You see that? How do you find that full angle of rotation? 180 plus my reference angle. So it would be 180 plus 84.3. 264.3. Does that make sense? So it's just drawing it out and logically reasoning through where does that angle fall, how does that fit within my restriction, and what geometrically can I do to find that angle. Yeah.
So if it's cosine, you'll always be going vertically, like to the other quadrant.
Correct. Yeah, because you're looking at where does it have the same x value.
Okay.
If it's sine, you're always looking at where horizontally those two things line up. And if it's tangent, you're looking at the opposite quadrant.
All right. Thank you.
Yeah. All right, I'll give you guys about 10 minutes to work on your own. Again, the key is already posted. What's that? Sure. There was a lull, so I didn't know if there was any other questions, but okay. Number siete? Really, this one?
Yeah.
Let's go.
You multiply by 180 over pi, and then you cancel out the pi's.
What's the other one?
No, I don't know. Pi over 180?
No.
I don't know what you're talking about. I can cross cancel a little bit here. Look at this. Presto changeo. That's 20 times 5. So 100 degrees? That's pretty warm. Pi over 180. You're looking at me like I'm crazy.
I think I'm just stupid.
No. All right, I'm going to let you guys work for the last 10 minutes of class. Again, the answer key is posted online already. If you'd like to get a jump on your exam review, by all means, you gotta, maybe you're going somewhere tonight, you got a long car ride or whatever, long bus ride, I don't know what you're doing tonight. You got a lot of time on your hands, you can print out the exam review. I'll be giving you an exam review copy. But again, everything's already posted online. It would be a good idea to check that out too. Check out those modules. Good time. Let me turn off the